Hello, everyone. I'm Tang Dexuan. I was responsible for the overall system architecture, the agent workflow, and the main orchestration logic of our travel planner. Our project is an agentic AI travel assistant. Instead of asking a large language model to directly write a travel guide, we divide the task into 4 stages: perceive, reason, action, and learn. After the user enters the city, travel dates, preferences, and free test, the request first goes through input guardrails. Then the orchestrator agent identifies the user intent, such as culture, food, night views, family travel, or a relaxed trip. After that, multi-agent trip planner coordinates attraction search, itinerary optimization, hotels, wider meal planning, task generation, and evaluation. The main feature of our part is the hybrid agentic AI architecture. The important designs such as which attractions to use, how to arrange daily routes, where to recommend hotels, and how to form same days are not fully delegated to the LLM. They are mainly handled by real data, rules, and algorithms. The LLM is only an optional test polishing layer, and it doesn't block the default planning pipeline. This design reduces hallucination, improves response speed, and makes the final plan more executable. For itinerary organization, I implemented the middle algorithm layer, including geographical clustering, single-day TSP ordering, remote attraction isolation, daily capacity control, and same-day planning for Beijing and Shanghai. For example, Beijing can be organized around the central axis, the Forbidden City, Imperial Gardens, and the Great Wall. Shanghai can be organized around the Bund and Lujiazui People Square Museums, the Henshan Fuxing Historical Area, and the westbound art spaces. This makes the itinerary feel like a real route, not just a list of attractions. Next, Yiheng will explain how the system retrieves real attraction, hotel, and image data. Okay.
Hello, I'm Yiheng. I was responsible for the data retrieval layer, including POI aggregation, AMAP REST API integration, hotel recommendation, and the image fallback pipeline. The first step in the travel planning is to obtain a reliable real-world places. Attraction search agent doesn't trust attractions generated directly by LLM. Instead, it expands keywords from user preferences and free text input, and then calls the AMAP web service REST API to search POIs. After retrieval, the system duplicates results by POI ID and name, filters out noises such as restaurants, shopping places, hotels, parking lots, interests, and visitor centers, and then ranks candidates using rating, scenic area level, city landmark priority, and whether the result is a minor attraction. To handle unstable API results, I also integrated created local attractions fallback design. Database. This means that even when the online result is weak, major cities can still return high-quality candidates, such as Forbidden City, the Bund, the Summer Palace, the Shanghai Museum. At the same time, it doesn't force all famous landmarks to the itinerary. They are used as search and ranking signals, so the file remains flexible. Hotel recommendation is another key part of my work. The system calculates the geographic center of each day's attractions, searches hotel within 2 kilometers first and expands to 5 kilometers if needed. It filters out unstable accommodation types and ranks hotel using rating chain brand signals and users preferring the hotel type. When no reliable real hotel is found, the system reduces fire. A clear accommodation area suggestion instead of inventing a hotel. For major sense, design fallback chain. The main planning API first use AMAP POI photos or correlate if an image is missing the front end image endpoint, then tries API by do back. And finally, a placeholder image. This keeps the main planning response fast. Next, Tanya will present the RAG weather recommendation and itinerary text models.
Hello, I'm Tanya. I was responsible for the planner agent related models, including agentic RAG, weather feedback, created meal recommendation, and final itinerary text generation. The first part is RAG. Our knowledge base is stored on the backend app data knowledge base and includes Beijing, Shanghai, and general travel knowledge, such as flight reason tips or reservation reminders, seasonal advice, and travel wallets. Because the project knowledge base is small, I didn't use a heavy vector database. Instead, I implemented lightweight TF-IDF retrieval with city weighting, so the system can prioritize knowledge related to the current destination. The second part is weather. Weather information is retrieved from the AMAP REST API first. If the API returns incomplete data, or if the travel days exceed the real forecast range, the system fills the gap using monthly city climate references. This prevents empty weather fields or unrealistic values such as 0 degrees from appearing on the result page. The third part is meal recommendation. A common problem in travel assistance is that they only see restaurants near the attraction, which is not actionable. I integrated the curated food database, which includes restaurant names, addresses, coordinates, average cost, meal type, area tax, and recommendation notes. When generating breakfast, lunch, and dinner, the system considers the day's attraction area, meal type, distance, and brand deduplication. So the user receives specific and executable food suggestions. The final part is trip planner agent text generation. To prevent LLM hallucination, the default pipeline uses deterministic templates to organize selected attractions, hotels, weather, and meals into a clear daily itinerary. The LLM is only used when explicitly enabled, and it must finish within a timeout. It's not allowed to add new attractions, change coordinates, or modify prices. This keeps the text neutral while keeping the data trustworthy. Next, Minze will explain guardrails, evaluation, observability, and human-in-the-loop design.
Hello, I'm Minze. I'm responsible for the responsible agent AI part, including input and output guardrails, automatic evaluation, agent ops, observability, and human-in-the-loop interaction. The first part is input guardrails. Before the request enters the agent workflow, the system checks whether the city, date, and travel dates are valid. It also redacts personal information such as phone numbers, emails, ID numbers, and bank card numbers for prompt injection, such as ignore previous instructions or system prompt. The system blocks the request or clears the free text field to prevent data agents from being affected. Second part is output guardrails. Since planner agent may use an LLM to polish text, I implemented output consistency checks. The guardrails verifies whether each POI ID in the final trip plan comes from the authorized candidate set, whether tickets, prices, and meal costs are abnormal, and whether each daily description only mentions attractions that actually exist in that day's plan. This prevents the LLM from adding unsupported places into the itinerary. The third part is evaluation agent. After a plan is generated, the system automatically evaluates it using 5 metrics: known landmark ratio, same-day geography, compactness, hotel rating, coverage, attraction field completeness, and whether the user's free text request has been addressed. Each metric has a weight, and the final report includes an overall score, a grade, and warnings. This maps to the learn stage of the course requirement because the system does not only generate an answer, it also evaluates the quality of that answer. The final part is observability and human-in-the-loop design. We provide endpoints such as API agent helps, API agent metrics, API agent evaluates, and API agent guardrail pre-check. These endpoints support agent health checks, image cache metrics, post-HOC evaluation, and safety pre-checks before submission. On the front end, users can review the plan, edit the itinerary, and decide whether to regenerate based on the evaluation results. This makes the system more transparent and more suitable for real users. And that is my part.